into our notes. Right. There we go. Cool. So here we are in week 6 of term 5. So that means we've only got 2 weeks left of class. We only have, what do we have today, tomorrow? So we only have 5 classes of IPC left before the end of the year. So this week, we're going to be talking about different types of ways, different units of measurements that scientists use in order to measure the world around us. The reason why I like to go through these is that they are a little bit different than the normal ones that you use and see every day. And that's because in science, we do not use the American system, or sometimes what is called the imperial system of measurements. So like feet or pounds or miles or inches, none of that is how scientists measure the world. Instead, in science, we measure using something called either the SI system or the metric system. So you may have heard about the metric system before. It has things like kilometers and grams and liters that it deals with. And a little bit later, we'll talk about why scientists like these a little bit better than the American imperial system. But first off, we're going to talk about what are these different measurements. So what are the different ways that scientists measure the world around us? So the first one that we're going to go over is length or distance. So in English and American usage, we use things like miles and yards and inches for distance, right? If we want to measure how far it is from here to there, this is what we use. But in metric units, we don't use that. We use things like meters and kilometers and centimeters. So in order to give you like a general idea of how big these things are, a meter is really, really close to a yard. So a meter and a yard are almost the same length. A centimeter, there's about 2.5 centimeters in an inch. So if you ever look at like a ruler in your house or something somewhere, and one side is inches and one side is centimeters, it looks something like this, and the smaller side is the centimeter side. So about 2.5 centimeters in an inch. And then there's about 1.5 kilometers in a mile. So a mile is in between 1 and 2 kilometers. So again, we're not using inches, feet, miles. We're using metric units, and the base unit, the like original standard unit for length, is called the meter, like we were just talking about. So a lot of times you'll see these units represented by letters so that you don't have to write out meter. It's like writing FT for foot or IN for inch. Meter we can just represent with the letter M. So 1 meter is that long meter stick. Is about the size of a yard. And one of the reasons why scientists like the metric system is that it's very easy to convert between smaller and larger units. What I mean by that is that in the English system, we have 12 inches in a foot and 3 feet in a yard and 1,100 yards in a mile. So all these random different types of measurements. In the metric system, it's all based on tens, hundreds, and thousands. So for example, a kilometer, also represented by km, If you took 1,000 meter sticks and laid them end to end all in a line, you would get 1 kilometer or 1 kilometer. So you'll notice all these words that we are going to go through have the word meter in them. So a kilometer is 1,000 meters. 1 km is 1,000 m's. Like I said, it's in between. It's almost the length of like half a mile. A meter is made up of 100 centimeters or cm's. So in 1 meter stick and 1 meter, we can split it up into 100 pieces, and each of those pieces would be a centimeter. We can also, if we split that meter up into 1,000 pieces, we would have 1,000 millimeters, or a little m. So meter is our base, and then kilometer is our bigger unit, and then centimeter and millimeters are our smaller units. And again, it's all based on tens and hundreds and thousands, right? So there's 1,000 millimeters in a meter. There's 100 centimeters in a meter. There's 1,000 meters in a kilometer. All based on these nice big round numbers. So that is how scientists measure units of length or height using the metric system. So like the distance between this school and your house, you would probably measure in kilometers. The height of a person or how tall your house is or apartment is would probably be measured in meters. How long that like your arm or your leg is, or how long that like a table is, would probably be in centimeters. And then millimeters would be things for like super tiny, small things. So meters, kilometers, centimeters, millimeters, all are different ways of measuring length. So that is our first style of measurement. Our second one is mass, which is just another way of saying how heavy is something here on Earth. So the mass is how much stuff you have inside of you. And in science, we measure mass based on your weight here on Earth. So again, if you're dealing with the English system, we use things like pounds and ounces and tons, right? If something's really huge, you measure it in tons. If something's kind of medium sized, you might measure it in pounds. If something's really small, like an amount of gold, you might measure it in ounces. Metric, we don't use that anymore. That's not what we're going to use. Instead, we're going to use things like grams and kilograms. So like 1 pound is about 500 grams, 450 grams. And so a little over 1 pound would be 1 kilogram. Or I guess a little over 2 pounds, I should say. So gram, kilogram, milligram, these are our new measurements, our new metric or new SI system units. So as you might be able to guess, the basic unit of mass here is the gram, usually represented by a small g. So a gram is pretty small. It would be around the weight of like, I don't know, a paperclip or a hairband or a thing of postage stamps that you get at the post office. Those probably weigh like maybe 2 or 3 grams. So a gram is a really small unit of weight relatively. So if we take 1,000 grams and we pile them all together, we'll have the weight of 1 kilogram or a kilogram. So a kilogram is 1,000 grams. a kilogram is a little over 2 pounds. It's like 2.2, 2.5 pounds. And so I don't know why. I think it's just because this was the example that somebody gave me. But if you think about like a big textbook, like a big heavy textbook for like this class, this science class, for example, I used to have some. Oh, hey, here's one. So if you think about a school textbook like this one right here, this probably weighs about 1 kilogram. So 1 kilogram for a textbook. People are usually somewhere around like 70, 80, 90, 100 kilograms, depending on the size of the person. So a kilogram, pretty hefty unit of measurement, a little over 2 pounds. And then if you took that 1 single gram, which is already very light, and broke it up into 1,000 pieces, you would have 1,000 milligrams. So a milligram is super duper small, a super duper light amount. Like if you think about like medicine that you take, like Advil or Tylenol or something like that, there are those little tablets, but they usually have between like 200, 300, 400, 500 sometimes milligrams of medicine. So even in that one really small tablet, there could be 300 milligrams of ibuprofen or acetaminophen, which is the medicine that helps reduce pain and headaches and fevers and all that sort of good stuff. So 1 milligram is really, really small. If you put 1,000 milligrams together, you get up to the size of a gram, which is pretty light. And then if you put 1,000 grams together, you can get up to a kilogram. So again, nice big round numbers, right? Everything is based on ones and tens and thousands. So 1,000 milligrams make up a gram, and 1,000 grams make up a kilogram. Just like before, we had 1,000 millimeters in a meter and 1,000 meters in a kilometer. So very consistent, very similar naming. Again, all reasons why scientists like this metric system so much. All right, before we keep going, any question? I know I've just thrown a whole bunch of new kind of terminology at you guys. Some of it you may have heard before, some of it maybe not. But does anybody have any questions so far about using meters to measure distance or grams to measure weight, anything like that? All right, thanks, Rose. Let me grab some water here real quick. All right, okay. So up next, the final basic type of measurement that scientists like to make about matter is the volume, how much space that matter takes up. So you may have heard of some of these volume units before, because a lot of these you can find at a grocery store, right? Things like liters. So you've probably gotten a 1 liter or 2 liter bottle of soda before, right? So a liter is actually not a English or not an imperial unit. It is a metric unit that tells us about volume. It tells us how much soda is in this thing of Coke or this thing of Pepsi or whatever it is that we have. So liter is very similar to a quart. So a quart is 1/4 of a gallon. So a gallon is almost 4 liters. It's like around 3.8 liters goes into a gallon. So again, very similar in size to a quart. So if you ever see like the really skinny, small things of milk at the store, or like quarts of motor oil that you get at like AutoZone or something like that, that is really close to a liter. So volume is all about the amount of space that an object takes up. So there's a base unit called the liter, like I was just talking about. This is really good, especially if you're dealing with liquid volumes. And so a lot of times people will represent liter by either a big L or a little l, depending on which one you prefer. I personally like using the big L just because it makes it look different from a 1, which can be sort of confusing sometimes. You can also, there's also another way to measure volume called cubic centimeters. So if you see this little 3 hanging out the top right here, that refers to a cube of something. So you may have seen in like algebra and stuff, this be a 2 for square, where you do like the same number times itself twice. Cubic just means you've added on a third number. And so cubic centimeters is just the amount of space that like a solid object takes up. So like this box down here has a length or a height and a length and a width, and they're all equal to 10. So it's 10 centimeters tall, 10 centimeters wide, and 10 centimeters long. So 10 times 10 times 10, we have 3 centimeters that we're putting together, and it makes up 1,000 cubic centimeters. So the volume of this box right here would be 1,000 cubic centimeters. So that's how you read this. You can also say centimeters cubed sometimes too. So that's another way to measure solid volume. So when we're dealing with liters, we usually don't, for whatever reason, scientists don't really like using kiloliters. They mostly just stick with liters and milliliters. So as you might imagine, 1 liter is the same as 1,000 milliliters. So again, a liter is like the size of one of those like big kind of skinny Coke bottles from the store. And then 1,000 milliliters goes into a liter. 1 milliliter is pretty small. I usually like to think of it, a milliliter is about the size of like a dropper, like if you're ever using like a dropper bottle for like eye drops or something, or you have like the little rubber plunger thing to take some drops out of something. Each one of those drops is probably about 1 milliliter. You can also think of it as like a raindrop. It's like on a normal rainy day, not like a crazy thunderstorm or hail or anything like that. But on a normal rainy day, each single raindrop is probably about 1 milliliter. So a milliliter is like a single drop of water, and then you put 1,000 of them together and you end up with 1 liter. The cool thing about milliliters, just as kind of a side, is 1 milliliter is the same volume as 1 cubic centimeter. So they take up the same amount of space. Okay. So volume, mass, and length are 3 major measurements that scientists take about the world around them. And most other measurements, most other things that scientists study are made up of a combination of those 3 amounts: length, mass, and volume. So volume is how much space an object takes up. It's represented by liters or L's. Mass is how heavy that something is, and it's represented by grams, G. And then distance or size or length is measured by meters, represented by an M. All right. Anybody have any other questions so far? Anything about grams, meters, or liters that you're still a little bit confused about? Righty. All right, so that part is pretty straightforward, just some different ways of thinking about types of measurements that you're already familiar with in terms of weight, size, and volume. Up next, though, is where we're going to take it to the next level a little bit. Because we want to be able to convert between different sizes of these metric units, right? So if I have something that's measured in meters, I would also like to know how many centimeters is it, or how many kilometers is that? And same thing for the grams or the liters. Luckily, because everything is based on tens and hundreds and thousands, you don't have to go in and like divide by 12 to go from inches to feet, or multiply by 5,000 to go from miles to feet. Instead, there are these really simple conversions that we can do in order to figure it out. And the way that I found works really well for people, or a way to kind of introduce it that I've found that people work really well with, is something called the ladder method. And it's a basic series of 3 steps that you can use in order to figure out if I have this many of one unit, if I have this many liters, then how many milliliters do I have? So the way that the ladder method works is it looks something like this. So here we have our different units arranged from biggest to smallest. So there's some on here that we didn't really talk about, like hecto and deca and deci. So don't really worry so much about those ones. The main ones that we're going to focus on are our kilo units. Kilo stands for 1,000 in the metric system. So kilo is up here at 1,000 units. We have our base unit right here. So if something is just labeled as 7 meters or 12 grams or 13 liters, those guys are our basic units. Meters, liters, and grams make up our base units. So then over on the smaller side, we have centi, which is like 100th of something, and then milli, which is like 1,000th of something. So kilo, centi, milli, and our base unit right here in the middle. These other guys we're not really going to focus on, but it's important for them to be here because they're going to act as the steps of our ladder. So the way that the ladder method works, the first thing that you have to do is determine your start and end points. Where are you going to start and where are you going to? So let's say, for example, I had something that was 4 kilometers. I measured a distance of 4 kilometers. And I want to know how much is that in meters? How many meters are in 4 kilometers? So my starting point, the one that I'm starting off with, is kilometers. And kilometers are way over here on our ladder. And my ending point is meters. And meters is a basic unit right here. So we're going from kilometers to meters. So we're going to be going to the right on the ladder, right? Kilo is over here. Meters is over here. To get from kilometers to meters, we've got to go to the right. So starting point, ending point, check. Next step is to count the jumps from the start to the end. And by that, I mean if we start at kilo and go to meters, we're going to use each one of these boxes like a step on the ladder and step down to our meters. So we're going to go 1 jump brings us here, 2 jumps brings us here, and 3 jumps brings us here. So it is 3 jumps from kilo to our base unit, from kilometer to meter. And we traveled to the right. So we went from here to here, we went to the right, and we jumped 3 times. The next thing that we have to do is move off of our ladder and go over to our number. And we're going to use the number of jumps that we just did and the direction that we just moved in to move our decimal point. So like right here, 4 is a whole number, so the decimal point, you could think of it as being like right behind 4. And I just mentioned that it's 1, 2, 3 jumps to the right in order to go from kilo to meter. So these 4, we're going to take it and go 1, 2, 3 jumps to the right. And the important thing to remember about doing these decimal jumps is that wherever you end up with a blank space where you don't have any numbers that you're jumping by, you're just going to fill that in with a 0. So when we jump 3 spaces to the right, 1, 2, 3, we're going to put a 0 here, and a 0 here, and a 0 right here. And that is going to give us 4,000 meters. So our decimal point started right here behind the 4. And then we said we had to go 3 to the right. So we went 1, 2, 3 to the right. Now the decimal point is over here. And we fill in those 3 empty spaces with zeros. So our final answer is that 4 kilometers is equal to 4,000 meters. So figure out your starting and ending point. Figure out how many jumps and in which direction you have to go from one to the other. And then finally move your decimal point that many jumps in that direction. So that is the easiest way to convert from one size of unit to the other, at least at first. After you do it a lot, you kind of get the hang of it and you're able to do it kind of in your head. When you're first starting out, using this ladder method I found is the easiest way to go. You do starting point, ending point, count your jumps, and then do that same number and same direction of jumps with your decimal point in your number. All right, so we'll do a whole bunch more examples of the ladder method to make sure that you guys really get it down. But is there anything about this so far that you're still really confused on or still really not sure about where we're going? All right, so everybody feels kind of sort of okay with the ladder method so far. All right, well, let me show you guys some more examples, and then I'll have you guys do some examples with me just to make sure that we're all good to go. So let's see here. I'm going to check and see if the person who filled in these answers on this slide did them correctly, at least for a couple of them. I'll kind of pick and choose. So this person says that 1,000 milligrams is the same as 1 gram. So first off, we're going from milligrams to grams. So we need to figure out our starting point and our ending point. So mg, milligram, is our starting point. So that's over here. Here's our milli. And then grams are a basic unit. So grams, liters, meters, they're all basic units. So milli is our starting point. Grams, our basic unit, is the ending point. So in order to go from the start to the end, I'm moving to the left. So we're going opposite this time. We're going from a smaller one to a bigger one. And we're going to go 1, 2, 3 jumps to the left. So we start at milli. We're going to go 1, 2, 3 jumps to the left. So we need to move our decimal point in our original number 3 spaces left. So it starts off right here, right at the very end of our whole number. And then we're going to move 1, 2, 3 spaces to the left. So now we don't have 1,000, 1,000 anymore. Now we have 1.000, which is the same thing as 1. So 1,000 milligrams is the same as 1 gram. We jumped 3 spots to the left on our ladder. So we moved our decimal point 3 spots to the left on our numbers. Sometimes you may have a number that already has a decimal point in it, which is handy dandy, like this guy right here. This is trying to tell us that 1.6 liters is the same thing as 1,600 milliliters, 1,600 milliliters. So I want to see if that's true. So we're going to go from liters, which is one of our base units, to milliliters, and milli is down here. So liters, base unit, milliliters is a milliunit. So we're going to be going to the right once more. And from the base unit to milli, we go 1, 2, 3 jumps to the right. So 1, 2, 3 up here. That means we're going to take this decimal point, which they've been so kind to show it right for us in the number here. And we're going to go 1, 2, 3 jumps to the right. So 1 jump puts us past the 6. 2 jumps gives us an empty space, so we'll fill that in with the 0. 3 jumps gives us another empty space, so we'll fill that in with a second 0. So we started off as 1.6, but now after jumping 3 to the right, we have 600 that we fill in. So this is correct. Our final answer here is 1,600 milliliters. 1.6 liters, if we move this decimal point 3 points to the right, gives us 1,600 milliliters. All right, I'll go ahead and do one more example for you guys, and then I'll bring up a whiteboard and have you guys help me do a couple more examples as well. So finally, let's look at this guy over here. 160 centimeters, they're telling us is the same thing as 1,600 millimeters. Okay, let's check and see if this is true. Centimeters, cm, that's centi, so it's one of the smaller ones. So we're going, here we go. Centimeter is right here. There's our starting point. Millimeter is right here. This is our ending point. So we're right next to each other in this case. Once again, we're moving to the right. And this tells us that to go from centimeters to millimeters, we are going to jump one step to the right. Okay, one step to the right. That seems pretty easy. So we start off with our decimal point right here, and then we're going to move it one step to the right. That gave us a blank space, which we're going to fill in with 0. So now, instead of having 160 centimeters, when we jump one spot to the right with our decimal point, now we have 1,600 millimeters, 1,600 millimeters. So again, starting point, ending point, we took one jump to the right to go from the starting point to the ending point. So we move that decimal point one jump, and now all we do is add an extra 0 onto our number and call it a day. So 160 centimeters is equivalent to 1,600 millimeters. All right, so hopefully those examples helped out a little bit in terms of kind of figuring out what's going on with our ladder right here. I'll have you guys help me out with some examples here in a second. But for now, is anybody still confused? Is anybody still not really sure how this ladder method conversion stuff works? All right. Not hearing anything. So to me, that says that everybody feels pretty okay with how to use this ladder method so far. So let me go ahead and bring up a whiteboard really quick. And I'll work on some questions and have you guys pop in to give me some help. All right, so let me share that screen for you. There we go. All right, so let me go ahead and draw a really quick example of our ladder. So we had kilo up here, and then we had like some of those in-between ones that didn't really matter so much. And then we had our base unit right here. So this could be meter or gram or liter. And then we had another one of those kind of in-between ones. And then we've got our centimeter and our millimeter. All right, there we go. So let me see what a good example I want to work with you guys would be. Oh, okay, I like this one. 198. So I want to know if I have 198 grams. What is that in kilograms? So 198 grams, and I want to convert that to kilograms. So first thing to do is figure out my starting point and my ending point. So if I'm starting off with 198 grams, which of these boxes is going to be my starting point? So feel free to answer either out loud or you can write it down in the chat as well. We've got our kilo box, we've got our base unit box, we've got our centimeter and our millimeter box. So which one of these boxes, which one of these steps is going to be our starting point for this conversion?
Is it going to be K?
It's not going to be K. So K is not our starting point because remember, we're starting with 198 grams. So if we're starting off with just normal regular grams, then what is going to be our starting point?
The base unit?
Yeah, there you go. So our base unit is our starting point right here. So anytime that you have just regular old grams or regular meters or regular liters, that means that you're dealing with the base unit right there. So everything else is sort of based around those units, right? We can have kilometers, we can have milliliters, we can have centimeters. It's all using those base units as the starting point. So yes, normal grams means that base unit is where we're going to start. What about our ending point? If we're going to kilograms, then where is our ending point?
Would you then be going to K?
Mm-hmm. Exactly, Rose. This time we are going to the K. So kg stands for kilograms, and kilo is our big one up here. So we have our ending point right here. So we are starting with our base unit. We are ending with kilograms. So actually, I'm going to write a little S for starting over here and a little E for endpoint over here. So starting with the base, ending at kilograms. All right, step one accomplished. Step two is doing our jumps. So first things first, what direction are our jumps going to go? Are we going to jump to the left or are we going to jump to the right?
To the left?
Mm-hmm. Exactly. If we're starting with our base unit and we're ending with our thing, then we are going to be jumping to the left. All right. Next step of part two, how many jumps does it take? How many jumps to the left do we have to do in order to go from base unit to kilograms?
3.
3. Exactly. We're going to do 1, 2, 3. 3 jumps to the left to go from our base unit to our kilograms. So step 3, now let's do that with our decimal point. So we have 198 grams. This is a whole number, which means that our decimal point is hiding out invisibly at the very end here. 3 jumps to the left means we're going to go 1, 2, 3 jumps to the left. So our new decimal point is going to be right here. So we started right here. We made 3 jumps to the left with our decimal point. Now it's over here. So how many grams, if we have 198 grams, how many kilograms do we have? What is our final answer for kilograms?
Would it still be 0.98 kilograms?
Close. It's not 0.98.
I mean 0.198.
Hey, there you go. Exactly. So when we put the decimal all the way in front, all it means is that now we have 0.198 kilograms. Or you could also do 0.198. It's the same thing. But yes, exactly. 198 grams is the same thing as 0.198 kilograms. So we found our starting point with our base unit and our ending point up at the K for kilo. We figured out that we're going to have to jump to the left 3 times in order to go from our starting point to our ending point. And so when we moved that decimal point 3 times to the left, we went from 198 grams to 0.198 kilograms. So that is our answer. All right. Very, very good, Rose. I hope everybody else was keeping up as well. Let's go ahead and do 1 or 2 more of these. Make sure that everybody feels good. So let me, I don't know what I'm doing that for. Reset this, although I'm going to keep my ladder just so that I don't have to recopy it again. So we'll go like this, and then this, and this. Racy thing up here. Okay. Same ladder as before. So let me find another good example to do with you guys. Ooh, here's a good one. All right, so I have 75 milliliters, and I want to know how many liters do I have? So I want to convert from milliliters to liters. I want to know how many liters is the same as 75 milliliters. So first thing that we got to do is figure out our starting point. So anybody not named Rose Oliver, if we are dealing with 75 milliliters, then where is our starting point on our ladder? Again, feel free to answer either in the chat or in person, but where are we going to start if milliliters is what we're dealing with?
Millimeters.
Oh, look.
So the milli is down here at the little m. So here is our starting point right here. I'll put a little s here. Thank you, Mr. Bueno. What about our ending point? If liters is what we are going to, then which one of these boxes, K, base, C, or M is going to be our ending point?
Would it be K?
It would not be K. Remember, K would mean we were dealing with kiloliters. We're not dealing with kiloliters. We're dealing with regular liters.
Oh, so the base unit.
Base unit, precisely. Remember, meters, little m, grams, little g, or liters, big L or little l, is our base unit. This is going to be our ending point. So K would be for things like kilograms or kilometers. And then C is things like centimeters. And then M would be things like milligrams or millimeters. All right, so we're starting at meters or millimeters, or the milli, excuse me, and we're going to the base unit. So once again, step 2, what direction are we going to jump? Are we jumping to the left or are we jumping to the right?
You be jumping to the left.
Exactly.
I don't even know how 3 times to the left.
Oh, Ruben's even got the number 3 times to the left. So precisely, we're going to be jumping from the left to go from here to here. And we're going to make 1, 2, 3 jumps. 3 jumps to the left. So here, 75 milliliters. That's a nice big round number. So that means that our decimal point is here at the end. So we're going to jump 1, 2, 3 spots to the left, right over here. So we jump past the 5, we jump past the 7, and then we make another jump, which leaves us with this blank space right here. And does anybody remember what number that we put in the blank space?
0.
0, precisely. So if we have 75 milliliters, then what is our final answer for liters?
0.075 liters.
Exactamundo.
0.075 liters.
Yep, nailed it, Mr. Bueno. 0.075 liters. You could also do 0.075. It's the same thing. I like putting the 0 out here in front just because I feel weird leaving a little decimal point all by himself. But exactly, 0.075 liters. 75 milliliters is the same thing as 0.075 liters. So we figured out our starting and ending points. We figured out the number and direction of the jumps. And we applied that to our little decimal point down here. 1, 2, 3 jumps to the left means we go from 75 to 0.075. All right, very, very nice, very, very nice. Let's do one more of these. Make sure that everybody has got this down. All right, get rid of some of these little notes here. Okay, get rid of this, get rid of this, and get rid of this. All right, let's do one more example. So let's say I have .18 kilometers. This is a K, not an R. Kilometers. But I want to know how many meters do I have? So 2.18 kilometers, but I want to turn that into meters. So we're starting from kilometers. We're going to meters. So what is our starting box? Where are we going to start on the ladder?
Kilo.
What was that?
K.
K. Exactly. Rose's favorite box. K, because we have kilometers, and kilometers means we start up here at the kilo box, the K box. So this is going to be our starting point. And then if we are going to meters, what is our ending point going to be?
Base unit.
Base unit, exactly. Meters are a base unit. So here is our ending point. So which direction are we going to be jumping to go from the start to the ending point?
You're going to be jumping 3 to the right.
Oh ho ho. Rose says 3 to the right. Let's make sure she's done her counting correctly. So we're starting at K, and we're going to go 1, 2, 3 jumps to the right. Hey, look at that. She nailed it. So we're going to take our decimal point, and move it 3 jumps to the right. So here is our decimal right between the 2 and the 18. So we know where our decimal is, so it's easy to find its starting spot. And we're going to jump 3 spots to the right. So we're going to go 1, we're going to go 2, we're going to go 3 spots to the right. And remember, this is an empty space right here, which gets filled in with a 0. So if I have 2.18 kilometers, then how many meters do I have?
Would you have 2,180 meters?
I would have exactly 2,180 meters. So, oh, that's weird too. Sorry about that too. But regardless, 18 kilometers is equal to 2,180 meters. Started from kilometer, jumped 3 to the right to get to our base unit. So we took the decimal point in here and jumped 3, 1, 2, 3 spaces to the right. That gave us a little 0 blank space right at the end there. So we figured out that 2.18 kilometers is the same thing as 2180 or 2,180 meters. All right, awesome. So that is how you use the ladder method. You figure out where your starting and ending points are, and then you jump however many spaces you need to get from the starting point to the ending point. And then you do that same number of jumps in the same direction with your decimal point on your number. And that will tell you how to convert from one size of your units to another. All All right, thank you guys for your help on that. Does anybody have any more questions about the ladder method? Any of these examples that we did where you're not really quite sure how we got to some of those answers or some of those numbers? All right, awesome. Well, hopefully you hold on to the skills that you developed here, especially with this stuff today, because they're going to become very much and helpful tomorrow. So let me go back to our notes here. All right. So I will say on the notes for today, I posted the normal Google Slides like I usually do. But then I also posted an additional slide that is just the ladder on its own, or just that one slide that showed that unit ladder. This way, if you ever want an easy way to go back and find that ladder again, if you want to use it in future homeworks or future tests, then you'll have it available for you to use. So today's assignment has to do with a little bit more review of some of these basic units. So I think there's one, the only one that we didn't really talk about today is time. So we talked about mass and length and volume. We didn't really go over time, mostly because time is the same no matter where you go or what standard you use. You're always going to have seconds, minutes, and hours when you're dealing with time. That's going to be the same no matter what. So the first part is I give you the unit, and I want you to tell me, does this represent a measurement of length, of mass, of time, or of volume? So you have things like mLs and cm3s and mgs. And I want you to tell me, does this tell you how heavy something is, how tall or wide something is, how much space something takes up, or how much time something is? Then there's a little bit of a flip version of that where I give you the name of the measurement, and I want you to tell me the symbol. So like, is milliliter represented by kg or L or mm? And then same for milligram and centimeter and kilogram and all that good stuff. So just write that 1 or 2 letter symbol that represents the measurement. And then finally, I want you to use those symbols or use those measurements to fill in the blanks on these types of scenarios. So you can get Coke at the store and 2 or 3 what measurement bottles. About how heavy is a bowling ball? About how long is a fly? How heavy is a paperclip? How much volume is in a tablespoon? So you don't have to know exactly, you just have to know which size and which type measurement would best fit this description. So that is today's assignment. Again, a lot of questions, but most of them you should be able to get through pretty quickly. Tomorrow's is all about those conversions that we are just doing. So tomorrow's assignment is just a whole bunch of examples of those conversions. So I give you a measurement like 160 centimeters, and I want you to tell me how many millimeters is that. How many meters are in 14 kilometers? How many kilograms are in 27 grams? How many meters is 50 centimeters? And so on and so forth. So you'll get a whole lot of practice doing those unit conversions on Wednesday, tomorrow. All right, so that's coming up for today and tomorrow. And then Thursday, we'll get into another type of measurement that combines the volume and weight aspect of what we talked about today and turns it into a new type of measurement called density. So we'll get into density next time that we come together on Thursday. Does anybody have any final questions on the notes for today or any of the homeworks for today and tomorrow?
No, sir.